Welcome to LTSpice, my tutorial for myself and anyone who got the opportunity, got the accidents, whatever, to see this kind of recording. So first I will just open a new schematic. Okay, now you open a new schematic, you need to have a circuit, and in this case I will try to simulate the AC transfer function of a low-pass RC circuit. So now let's have the resistor. Okay, one resistor, and to scale it or to rotate the direction, you choose rotate, and now you add a capacitor, and then you need to have a source. You right click, and in draft you choose components. To search for the voltage, we need a source, but a voltage source. So voltage, okay. So this source you can use for DC analysis, AC analysis. Only one source, simple, and you can do both for the DC simulation and AC simulation. Now we need to connect them. You choose the wire here. Actually, you can move around by the middle thing of your mouse. You can zoom in and zoom out. Now I'm moving around, zoom in, zoom out. Now I add wire, and wire. Done. And then we need to add a ground, otherwise your circuit doesn't have a ground. It might be an error for the simulation. So we add the ground. After we add the ground, we need to edit the value. For example, I want to have this one is the circuit, a simple circuit of an RC low pass filter, and I want to have the cutoff frequency or the breakpoint frequency around 1 kHz. So after all of my calculation in the paper, I found out if my resistor has the value of 1 kilo ohm, then my capacitor needs to have the value of around, let's say, 0.159 microfarad. Okay, and now you need to right click on the voltage. If you want to do the AC simulation, the AC transfer function of this circuit, you need to right click on the voltage, choose advanced, and then because you are doing the AC transfer function where you have the frequency sweep for the whole range, that's why you don't need to care about the function here. You only need to see the small signal AC. So let's put it AC amplitude as 1. As long as it's not 0, then you will have the same AC transfer function of the circuit. So don't worry about the value that you put here. Just put 1. I put 1 for simple. So for simplicity. So I click OK. Now I want to see the simulation. You go to simulate, you click run, and in AC analysis, in the type of sweep, I would just choose like normally when you draw the border plot of the amplitude, you will draw the dB scale of the amplitude versus the log scale of the angular frequency, and the log scale usually in decade. So I choose decade, number of points per decade. I would just, whatever, the more points you have, the more finer the graph will be. So star frequency, because I know that if I want to see the whole range of the circuit frequency, of the AC transfer function, I need to have a very big range of frequency. So let's say it cannot start from 0 to start from 10 and stop at 1 megahertz. Because I know that in this range the whole graph will be shown, but actually if you put one big M, it doesn't work. Okay, so you need to put properly 1 millihertz, 6 zeros. Okay, click OK. Now the plot appears. To see what is going to be on the plot, you just have to right click here. See, now you got the plot. This is the plot of the phase and the amplitude together. How can you split them? So let's say I just add plot plane, and from here I want to keep the phase. I want to keep this one. So on the amplitude side, right click and don't plot the magnitude. Okay, good. So to see what's gonna happen in the second graph, you choose again this output, and you see the same signals appears with the amplitude and the phase together. But now on this graph I want to see only the amplitude, so I keep the amplitude and I turn off the phase. Okay, great. Now we have the phase and the angle. Everything's perfect. If I want to see a specific value in the graph, click on the name of the signal. So one click, one cursor appears, see? And here you can see the values. For the values, you can just move around to see, like here is around 1 dB, very small, like 0 dB, almost 0 dB. And at the breakpoint frequency, it should have around like -3 dB, -3 dB, yeah, -3. See, around 1 kilohertz, you have around -3 dB. So my calculation in the circuit to choose the cutoff frequency or the break frequency around 1 kilohertz is correct. Now I want to see the phase, so let's click on this name. I add another cursor here, see, and let's see the phase. The phase around -40 degree, so it's correct. If you want to have more cursor, just click on the signal, the name signal again, and you can choose for the first one is the amplitude. 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 See? And the second one is the phase. Great, right? Great. Yep, I think that's gonna be enough for you. Or you can, if you want to change the simulation, you can click run, but it doesn't appear, right? So how can we do in that case? Right click on your circuit. Right click in the window of your circuit, choose draft, choose spice directive, and in this blank space, right click, help me edit, choose analysis command. So you will have the same thing happen again here, and for AC analysis, put things here. You click OK, for example, like decay, number of points, 100, start 10, stop 1 megahertz or something. Click OK. Now you have two options. If you run, there are two options for you to choose. See, yeah. So that's how you can have many kind of simulation options for one circuit in LTSpice, and to see the graph and create a graph. Good luck. Thank you for watching.